For our problem today, we will be doing number 53 on page 226, which is f of x equals x minus the log base of 4x. First, you want to write down everything you're trying to find, which is critical numbers, increasing and decreasing, and relative max or min. The first step of this process is taking the first derivative of the original function. If you do not remember the derivative of x or log, you can refer to the front of the book. The derivative of x is always 1 minus the derivative of log base of 4x comes out to be 1 divided by x times the natural log of 4. The next step is setting the first derivative equal to 0 because you are trying to find the critical numbers. Once you set it equal to 0, you want to isolate the term that has the variable in it. So, bring over 1 divided by x times the natural log of 4 to the right side of the equal sign, making it positive. To get x by itself, you have to multiply x to both sides. On the left of the equal sign, you will have x times 1, and on the right, you will be left with 1 divided by the natural log of 4 because the x's cancel. That leaves x to equal 1 divided by the natural log of 4, which is equivalent to 0.721. Now that you've found the critical number, it is time to determine the increasing and decreasing. To conduct the first derivative test, you will use what you got for x as a value. To determine the other values, you have to pick a value less than and bigger than 0.721. I picked 0.5 and 1. Since logs are not defined to the left of 0, you have to include 0 as a value. Draw a sign line and place all 4 values at the bottom. Each number will create a box to determine if it is increasing or decreasing. To test the values less than or bigger than 0.721, you have to plug them into the first derivative. So, 0.5 gives you back a negative 0.44, and 1 gives you back a positive 0.28. That shows that values less than 0.721 is negative, causing a dotted line, and values bigger than 0.721 is positive, causing to not have a dotted line. Because logs are not defined to the left of 0, it causes 0 to have an open hole. These two arrows are going down because the values are negative, and these two arrows are going up because the values are positive. After determining increasing and decreasing, you want to take the second derivative and set it equal to 0 to determine if there is point of inflection. So, the derivative of 1 is 0 because all constants are 0. Then, 1 divided by the natural log of 4 will sit out as a multiplier and leave that multiplied by the derivative of 1 divided by x, which is negative 1 divided by x squared. To get negative 1 divided by x squared from 1 divided by x, you change the sign and add 1 to the exponent. To get x by itself, you have to multiply it by both sides. To simplify even more, you will get negative 1 divided by the natural log of 4 times negative 1 equals 0. The final simplification is 0 equals 1 divided by the natural log of 4. This can't determine the point of inflection because there is no variable, which leaves it at empty set. Before graphing, you have to plug in x to the original function to solve for the y-intercept. So as you can see, I plugged in x, where x goes, and I got back a 0.96. Also, you have to determine the x-intercept by solving for x in the original function and plug 0 in the original function for the y-intercept. So for the original function, I'm solving for the x-intercept. I isolated the log base of 4x and brought it over to the right side of the equal sign. And the x-intercept cannot be determined because I have two x's on both sides of the equal sign. So therefore, there is no x-intercept being used. For the y-intercept, I plug in 0 for each x, and I get back an empty set because when you divide the log of 0 divided by the log of 4, it is unsolvable. So therefore, you will not have an x-intercept or a y-intercept being involved. To finally graph this problem, all you need to know is to place what your x value was, which was 0.721, and your y value, which was 0.96. So you go over on the x-axis to 0.721 and go up to 0.96. And that will be where your dot is. Since there is no x and y intercepts, this graph will be this U shape. And since on our timeline we had two arrows going down, this means that values from 0 are going all the way down until 0.721. And from 0.721, it is going into infinity. And that is how you get the arrow over here and no arrow over here. And this is what your graph should look like at the end.